Section 6.4, number 13. We're going to solve this equation in 0 to 2 pi using factor by grouping as our hint, which is a pretty good hint since there's 4 terms. So that's a pretty good indication that we're going to be using grouping. So I'm going to use this group first. I'll call that my green group. And the other one, I'm going to keep that minus with the cosecant and stick a plus sign in the middle there. So my negative sign stays as a negative and not a minus, since that is not with the 2 also. So I don't want it to be in front of the parentheses. Okay, so looking at the green group first, I'm going to take the GCF of that group, and I see a cotangent x I can take out, which leaves me with cosecant x minus 2. And then I still have that plus sign because I haven't factored anything yet. I'm just factoring one group at a time. Then looking at the purple group here, I want what's inside my parentheses to end up matching this. So it looks like I'm going to take out a -1. So if I take out a -1, that leaves me with cosecant x minus 2, which matches on the left. Success. So that equals 0. Now I need a factor. Looking at this whole thing now, and I'm going to treat, let's pick a color here. This guy as a factor that's common to both of these terms. I'm going to put that out in front, cosecant x minus 2. And then when I'm left with, when I pull that factor out of each of those terms, I'm left with cotangent x minus 1. You'll notice my plus sign is no longer there because I'm factoring out, actually that plus sign turned into that. This plus and negative turned into that minus there. So when I factored out, I'm left with the cotangent x plus a -1, which is minus 1. So now I have that equals 0, and when I have 2 numbers multiplied together equals 0, I can use the zero product property, and that means that either cosecant x minus 2 equals 0, or cotangent x minus 1 equals 0. And then I can solve both of those. Let's do the orange one first. So that gives me cosecant x equals 2, adding 2 to both sides. And I'll take the inverse of both sides, the multiplicative inverse. So that gives me sine of x equals 1 over 2. And then I can take the sine inverse of both sides. That gives me x equals the sine inverse of 1/2. When I take the sine inverse of the left side, I just get x out. And then I'm solving in 0 to 2 pi, so I'm going to look at my unit circle, and I find that sine is 1/2 at pi over 6 and 5 pi over 6. Sorry about that. I was thinking ahead here. So on the right, I have cotangent of x equals 1, adding 1 to both sides, which means I have, let's see, I'm going to go ahead and change it to tan. It's not really necessary, but the inverse of cotan is tan. Not really necessary, but it's a little more familiar. But they're both equal to 1 at the same time, which is solving for x. I get tan inverse of 1, which it happens at, on the unit circle, it happens at pi over 4 and 5 pi over 4. And that gives me my 4 answers for number 13.